Welcome to a new part of the ISM Statistics 1 exercise set. This time with an exercise on measures of dispersion. Let's take a closer look at the exercise. The following dataset describes the output of a factory worker during the last 2 weeks. What's to do with this? First off, calculate the range, calculate the interquartile range, the corrected variance, and finally the corrected standard deviation. Well, before we however start with any of those 4 parts, we do one step before. And this one step is taking the data set and arranging this in an ascending order. So we start with the smallest values, that's here 3 times the 200, then we have 210, 230, again 250, then 270, 2 times 280, 290, and finally 300. Why did we do this? Because this will help us quite a lot in the next few exercises. We can see this directly if we start with part A, calculating the range. The range is defined as maximum minus minimum. Maximum minus minimum means largest minus smallest. And well, we have a data set in ascending order, so this means the largest value, the maximum, that's actually the last one, and the smallest one, that's the first one. So we get this by xn minus x1. So here it's the 300 minus the 200, giving us a range of 100. Before we carry on, some words on the range. If we consider box plots, the range actually measures the size of the whole box plot, from upper whisker to lower whisker. A little bit different is in the second part, the interquartile range, meaning what we have to do here is calculate the difference between the third and the first quartile. So in other words, the 0.75 percentile and the 0.25 percentile. To get this, what we're doing is we're multiplying the 0.75 with the number of observations, here with 12, and the 0.25 as well. So in other words, means in the first case we go 3/4 times 12 and the second times 1/4 times 12. And in each cases we get already an integer. So if we have an integer when calculating quartiles, when calculating any kind of percentiles or quantiles, then we're not simply rounding up as we would have done if we have some kind of decimal. Then we use a slightly different formula, meaning what we do here is we consider the number itself. So here we calculated 9, so we consider the value at place 9. That's here the 280 plus the number at place 10, so 1 place ahead. That's also 280. And then we take the average of those two. Same thing goes here where we have 3. So in this case we consider the average of third and fourth place. So third place 200, fourth place 210. So we take the average here. This rule only applies when we already have an integer, so a whole number at this point. In all other cases, you would simply round up, look up the corresponding value, and take this as quantile. So here in this case, well, look up 9th and 10th place. As we said, it's 280. Third and fourth is 200 and 210. Here the average is 280. Here the average is 205. So we get as a final result for our interquartile range 75. For the next part, the corrected variance, we have to do one preliminary step. We first have to calculate the arithmetic mean. However, this gets done relatively fast. We just add up all the different values, divide them by the number of observations. So here divide them by 12, giving us an arithmetic mean of 245. This arithmetic mean we can then use in the formula for the corrected variance, which is given here. This might look complex, However, it isn't. You just go on, take the data set, and square all the data points. When you have squared them, you add them up and divide them by n-1. So here, in our case, divide them by 11. From this, you subtract n divided by n-1, so here 12 by 11, times the squared arithmetic mean. How does this look in detail for our example? First off, we added up all the squared data points, divide them by 11, and then subtract 12 by 11 times the squared arithmetic mean. This whole expression is then entered into calculator and gives us a result of 1445.4545. This then already is our corrected variance. Getting the final part done, the corrected standard deviation, also is relatively easy, considering we already have the corrected variance from part C. So we just take this value, calculate the square root of this value, getting 38.0191, and this gives us our corrected standard deviation, concluding this part and also the exercise. Well, then I hoped all of you enjoyed listening to this exercise and learned something from it. Until next time, see you and goodbye.